Hi guys! So today we're going to be doing some notes about the scientific method. You're going to want to make sure that you have your notebook out, and we're going to be working with pages 10 through 12 today. So in your notebook, in your table of contents, you're going to want to, for page numbers, put 10 through 12, and for the title we're going to put scientific method. Just like last time, we're going to do our notes on the first two pages, and then we're going to do an output page on the third page. Alright, so let's get started. You're going to want to set up pages 10 and 11 for Cornell notes. So you're going to want to set up your two columns. Make sure that you put your essential question at the top of page 12, or excuse me, at the top of page 10. There's a typo on the screen. Again, that's going to go on the top of page 10. If you're an avid and you need to put a citation, you can put PowerPoint or teacher. The title, you can put scientific method. And the essential question is, how do scientists make discoveries? How do scientists make discoveries? If at any point in time you need to pause this video in order to write, go ahead and pause, because I'm going to go through just as long as it takes me to talk. So pause as needed. Alright. So science. What is science? Well, basically science is the study of the natural world around us. Now, a little bit more detail on that. Science is based on empirical evidence, which means it's based purely on observations and data. Without observations, without data, we have no evidence of something. And if we don't have evidence, then we cannot scientifically describe it. So empirical evidence and well-reasoned interpretations of data. So that's your observations and your inferences. Now, another thing we also say is science provides evidence. We don't ever say that anything is necessarily proven in science. And the reason we say that is because there's always a chance that further down the road, later in time, there might be more evidence that comes up, and it might conflict with what we already have seen. So we adjust our views in science based on the evidence we currently have. So at one point in time, what we thought the atom was, for example, that changed over time because as we got more technology, as better technology developed, we had a greater ability to get new evidence. So anytime new evidence comes up, and it happens a lot, anytime new evidence comes up, we have to look back at what we already know, and we have to find a way to fit that information in. And sometimes that means throwing out an old theory that's no longer relevant or accurate anymore. But basically, evidence drives science. Without evidence, it's not science. All right. Now, we follow a particular process of scientific inquiry. And this is a process of gathering evidence and proposing explanations based on that evidence. Now, a lot of times you hear that referred to as the scientific method. We're talking about the same exact thing right here. So the steps of inquiry are posing a question, researching information, developing a hypothesis, and a hypothesis, as you most likely already know, is a possible answer to a question or a prediction about what might happen. Now, this next step is very important. Testing the hypothesis using a controlled experiment. All of science, everything we learn, is through controlled experiments. We'll talk more about that in a little bit. Now, during our experiment, we collect data. So our next step is, of course, analyzing that data that we collected, and then finally drawing conclusions based on that. Now, usually after scientists go through all of this, there's a lot of retesting and going back and doing more experiments. And eventually, once a conclusion is drawn, scientists do share that information. They don't just keep it all to themselves. They share it with other scientists, and those other scientists will will try to back up their conclusion by doing that same experiment and seeing if they reach those same conclusions, if they get similar data. Okay. So this is a flow chart of basically what that looks like. Again, we start off with a question. We might make that question based on observations we've made. We form a hypothesis, we test the hypothesis, and we analyze the results, so we analyze the data. If the conclusion supports the hypothesis, then sometimes they go ahead and communicate the results. If it doesn't, if the hypothesis isn't supported, they might go back and they might retest it. It might lead to a new hypothesis being formed. If a hypothesis is not supported, that's not necessarily a bad thing, but we'll talk about that more in a little bit. Now, a controlled experiment. Basically, what this means is an experiment is done where only one thing is purposely changed. We want to keep everything else the exact same. So the only thing that is changed is called the independent variable. Now, we then measure something else. The factor that might change in response to the independent variable is the dependent variable. So for example, in the diagram on the screen, you can see a few different variables. So let's say we're doing an experiment with paper airplanes, and we're trying to see if the size of the paper that we use affects the distance the plane flies. So if we're using different size papers, let's say we're making an airplane out of a Post-it note, and we're making another one out of a piece of notebook paper, and another one out of a piece of poster paper, right? Those are all different sizes. Or maybe we might take the same a piece of notebook paper, and maybe we'll only use a half sheet or a whole sheet. So the thing that we are changing is the independent variable. So in this case, if we're changing the size of the paper is the thing we're changing. That's our independent variable. Now the dependent variable is whatever we're measuring. So for example, if we're measuring how far the airplane flies, that's our dependent variable. Now everything else we say is controlled, meaning we don't change it. We keep it exactly the same. So if I'm using different size papers, I might want to make sure that I'm using the same thickness paper. So maybe that example of using a Post-it note and a piece of poster paper, that might not work so well because those are different thicknesses of paper. So that might be an issue there. But if I'm testing the size of the paper and how it affects the distance the plane flies, I'm not going to want to change up my design from one size of paper to the next. I want to keep that design the same, because if I change it and the distance ends up changing as a result, then I'm not sure if that distance changed because of the size of the paper or because of the different design I used. So we only change one thing, we measure something, and everything else stays the same. So what we change is independent variable, what we measure is dependent, and it depends on the independent. So in this example, we're trying to test to see if the distance the plane flies depends on the size of the paper used. And then everything else is controlled. All right. Controlled experiments also collect data using repeated trials. We use repetition and replication. Now, repetition means repeated trials. I'm going to do the experiment multiple times to collect as much data as possible. So back to that airplane example. If I'm testing the distance an airplane goes, I'm going to want to throw that airplane multiple times because I want to get as accurate a result as possible. If I only throw it once, then I don't know if that's how it's going to be every time I throw it. So I want to throw it as many times as I can and maybe come up with an average so I can see exactly how accurate that is. Now, a controlled experiment also needs to be replicated. What that means is a different group of people can go in, they can perform the same experiment and get similar results. If something can't be replicated, if someone can't do that experiment and get similar results, then that means that it's not exactly valid. If a claim can't be replicated, if someone else can't get the similar results, then that tells us in science that, hey, something's up here, this isn't right, we need to figure something out. Now, conclusions. When we analyze our data, we come to a conclusion about our hypothesis. Was it supported? Was it not? Now, conclusions can lead to theories. Now, a theory is a well-tested explanation for observations of the world. Now, like I said earlier, we change our ideas based on new evidence. Many theories have changed over time because of new evidence being presented. Now, along with theories, we also have laws. Laws are descriptions of what scientists expect to happen every time something happens under specific conditions. So, for example, if I drop something here on Earth, we have gravity. Now, anytime we drop something and we are in conditions where there is gravity, we expect that thing to fall. That's basically the law of gravity. Law basically says this is going to happen. A theory attempts to explain why something has happened. Now, these two things can only come about after extensive experimentation, lots of evidence. There has to be a ton of evidence for a theory or a law, either one. Without the evidence, it can't be either. Now, if a hypothesis is not supported, it's still valuable. Even if a hypothesis isn't supported, it can lead to new questions, it can lead to new experiments, or it might have even just brought up new evidence that we hadn't seen before. And those are all good things. So a supported hypothesis a lot of times will lead to a theory or a law, but even if it's not supported, that doesn't mean it's not good. All right, that's basically it. So what you should be doing at this point in time, finish up your notes, and go ahead and do a summary. At the bottom of or below your notes, you're probably on page 11 right now if you write as big as I do. So below your notes on page 11, you're going to go ahead and write a summary. In your summary, you want to sum up all of the information. You want to try to answer the essential question. And remember, a summary in here is one paragraph. And again, in here, I consider a paragraph to be 3 to 5 sentences long. So aim for that length. When you're all done, you can begin working on your output page, which is going to be on page 12. And as a reminder, an output page is a page where you are making a visual representation of the material. So that could be something like a bubble map, describing maybe the different steps of scientific inquiry. It could be something like a Venn diagram where you're comparing and contrasting dependent and independent variables. The diagram that talked about the different types of variables, you could do something like that where you have diagrams and pictures describing something. So basically on an output page, anything goes as long as it is a visual representation of the material we've covered in the notes. Don't forget, if you have any questions about anything we've gone over, make sure you ask. Can't read your mind. So if you're having a hard time, I can't necessarily tell. So please ask if you have any questions whatsoever. Alright guys, thank you for watching, and we'll continue working with this material over the next few days. Thanks.